It is like a shield which is present around the earth. It is like the bulletproof of the earth. How we have the bulletproof which protects us from the impact. We see that the bulletproof around the earth is this magnetosphere. From where did the earth get its magnetism? Geomagnetism. Now when you talk about geomagnetism is nothing but, geo means what, my dear? Earth. And magnetism, we see that there are certain magnetic fields which are existing with respect to the earth. One small concept that was present was the dimensions of magnetosphere. And when we look at these dimensions of magnetosphere, that when you talk about magnetosphere, till now we were discussing about different structures of atmosphere. We were talking about tropo, strato, meso, exo, iono, thermo. But now we see one specific layer that has been existing with respect to the earth. That is what is magnetosphere. It is nothing but these are some series of magnetic belts which are present, and these are some series of magnetic belts which are present around the earth. And we also see the categorical purpose of such a magnetic belt which has been present around the earth was purely with respect to the nature of protection. It was more of a shield to the earth which is present. It is like a shield which is present around the earth. It is like the bulletproof of the earth. Like how we have the bulletproof which protects us from the impact, we see that the bulletproof around the earth is this magnetosphere. Now here you have to categorically understand, sir, from where did the earth get its magnetism? Because unless and until you understand that earth as a entity has a phenomena called as geomagnetism. Now when you talk about geomagnetism is nothing but, geo means what, my dear? Earth. And magnetism, we see that there are certain magnetic fields which are existing with respect to the earth. And when you look at, or when you trace the phenomena with respect to from where is the earth getting its magnetism, when you get to understand the interiors of the earth, right? On a later date in geomorphology, we would start our basic dimensions with interiors of the earth. But now just to make a passing reference, when I look at the interiors of the earth, I see that the earth can be divided into three different layers. The topmost layer is the crust. This is what is mantle. This is what is outer core. This is what is inner core. And just like in the context of wind systems, we were seeing the balancing, the imbalance condition, and the imbalance condition was with respect to temperature. In the context of oceanography, we will see that the balancing, the imbalance was with respect to salinity, temperature, and density. And in geomorphology, when you observe the balancing, the imbalance wala condition, it is majorly with respect to density difference. And when I look at the density difference that is existing with respect to different layers in the context of geomorphology or interiors of the earth, I see that that particular density difference is happening with respect to variation in composition. That means if I see that there is some variation with respect to composition that is existing, I will automatically realize that there is a variation in density that is present. So that is what is one small clarification that you need to understand. Iska matlab that when I look at crust, it is on the topmost. That means definitely it is having less density than mantle. Mantle is less dense than core. That means as it is above the core, it will definitely have less density than core. And when I see in the core also, outer core is less dense than inner core. And the whole concept of this variation in the density is happening because of what? Variation with respect to composition of each of this layer. Just like the variation of the temperature resulted in wind, variation in salinity, temperature, and density resulted in oceanic currents. In the similar manner, we see that geomorphology is all going to be managed by the variation in composition and density. Now, as part of this peculiar composition that has been seen across different layers, what do you observe when you look at the core structure? When you look at the core structure, now, hope you got this diagram, right? Now, if I have to just simply say, what is this diagram? Now, just imagine watermelon as your earth. Watermelon, right? How do you check a watermelon? You make that fellow cut it in the middle, you take out that, right? That removed part is this, right? This is the center of the watermelon. जो ऊपर crust है ना, जो green color वाली layer है, that is this. And बाकी का part is the mantle and the core. Visualization. All right. Yes or no? Right. So that is what is one. If you, sir, you're going very organic, right? So if you want to still think about some yo-yo dude example, think about pizza. Right now, when I look at one slice, what happens? I remove it. The border one part is the crust. The middle part is the mantle. And something which is close to the center of the pizza is core. Right? ठीक है. Gen Z. So I can't do anything. ठीक है. Watermelon all. Right? In that also you have some flavors again, right? So ठीक है, you see, so density and variation with respect to composition. Now when I look at this core wala part, what do I understand when I look at the core? I see that this particular composition of core is having the composition of nickel as well as iron. The core is known to have nickel as well as iron. And when I look at this composition of nickel and iron, and when I look at the variation that is existing with respect to the outer core and inner core, I see that the substance which is present in the outer core is more molten in nature. It is more molten in nature. Whereas in the inner core, I see it is not molten in nature, but it is solid. Now you might get it out, sir. In spite of so much of pressure that has been applied by your mantle as well as the crust, how can some structure in the interiors of the earth exist in a molten form? That is what is one fundamental doubt that you might get, right? Now, apart from that, sir, why is this variation categorically happening? Now, when I look at this corresponding variation that is happening, I see two factors playing out here. There's an interplay of two factors. When I find this interplay of two factors, one particular factor is the temperature. The other factor is the pressure. Now, when I find this interplay of both temperature and pressure, I see a variation with respect to state of matter that is existing in outer core and inner core. When I observe the outer core wala business, I see that in the context of outer core, the temperature is going to be more than the pressure that is applied by the above layers. And when I look at the inner core, I see that the pressure is going to be greater than the effect of the temperature that is existing. That is why I see that there is a solid nature in the inner core and molten form in the outer core. Now, one fundamental question will again arise that I don't know whether you have thought of or not. Sir, from where did the temperature come? Akini, right? Why does the interiors of the earth appear to be hot? Why? Lava is being generated because it is hot. Right? Oh, molten form hai na. Why is it being melted? Because there is some temperature. What is the source of the temperature? Earth formation, friction. क्या फ्रिक्शन है यार, इसमें मूविंग पार्ट्स कहाँ है? ये तो पूरा सॉलिड है. कुछ any clue that you have? Some exothermic. आप इंजीनियर हो? नहीं. एक्सोथर्मिक, हाँ ठीक है. कौन सा एक्सोथर्मिक है? डेफिनेटली एक्सोथर्मिक, बट कौन से एक्सोथर्मिक रिएक्शन चल रहे हैं? हाँ, beautiful. You didn't think about that, right? You didn't ask me, right? Sir, from where did the temperature come inside? Okay. Now you have to understand that in the interiors, what is happening is I see a process constantly going on, that is a process of radioactive disintegration. When I see this process of radioactive disintegration constantly going on within, what is happening? It's a kind of very similar or synonymous to fission reaction. When I see that it is very similar to fission reaction which is going on, what do I see? Breakage of the bonds will release in energy. And all which is constantly going on will fundamentally result in what, my dear? Some heat energy or temperature. Now, because of this temperature, what happens? I see that the outer core, in the context of the outer core, the factor of temperature is dominating the factor of the pressure which is being applied by the above layers. Now, because of which I see that there is a molten state of outer core compared to inner core. Basic understanding. Now here, sir, why are you discussing so much upon this molten core? Now when I see this molten core, which is the outer core, and what composition of this molten core, my dear, majorly it is nickel and iron. And I constantly know, and I definitely know, that there is one movement which is happening in the context of the earth is what is? Rotation. When I keep seeing this rotation going on, what is happening? This molten form which is existing within, that is also seen to be put in a convective movement. That is also seen to be put in a convective movement. That means there is a constant movement of this molten material in a circular motion because of what? The rotation of the earth. Now when I see this constant movement of the molten material, molten iron in a convective current that is going on, what do I see, my dear? I see the dynamo effect existing. Now when I see this dynamo effect coming into the picture, this dynamo effect which has been induced because of the continuous currents which are generated because of the rotating molten iron inside the core, this will result in a phenomena of what? This will result in a phenomena of magnetism. That is where I see the source of geomagnetism. That is where I see the source of geomagnetism. I see that it is purely generated because of the continuous movement of the molten iron in the core. Because of the continuous movement of the molten iron within the core, because of the dynamo effect, I see that there is this generation of magnetism called as geomagnetism. Now, this geomagnetism as a phenomena, this magnetic effect with respect to the earth, what do I see with respect to this magnetic phenomena here? What is the corresponding effect that I see with respect to this magnetic phenomena? I see that this dynamo effect, this magnetism as a phenomena, it will result in that I see some sort of magnetic effect which is existing with respect to the earth. This is the earth. These are the magnetic fields which are existing around the earth. Why is this magnetic field existing? Because of the dynamo effect. Why is this dynamo? Because of the constant movement of the molten iron. Where? In the core. So from this place, I see this magnetosphere emerging. From this place, I see the magnetosphere emerging. So if I'm saying this is the earth, I see that this is what is the different radiation belts or different magnetic belts which are existing around the earth. And this is what is turning out into a magnetosphere. The business is this. Now here we'll just move one more step ahead. Now when I just move one more step ahead, now here we have our beautiful source, that is sun. And what is happening here in the context of the sun? We see that because of the activity, because of the fusion, because of all sorts of activity which is going on, I see that constantly the magnetic field or magnetic field is ejected. There are solar magnetic ejections, solar mass ejections, solar flares, solar winds, solar storms. Yesterday we discussed. All of these are what? All of these are nothing but the magnetic ejections which are being released from the sun. When I find these magnetic ejections being released from the sun constantly, what happens is if the magnetosphere was not existing, don't you think the earth would have been impacted by this magnetic field? Now, when the earth would have been impacted by this magnetic field, can we have any sort of EM wave propagation which is happening? No. Why? Because here EM wave propagation is what, my dear? Electromagnetic waves. I will definitely see any electromagnetic wave will be interfered by one more magnetic wave or maybe some electric wave. So when I didn't have this, in case if I didn't have this magnetosphere layers, I would have definitely seen the Earth's electromagnetic wave composition could have been distorted. And we would have never had satellite communication. We would have never had internet. In fact, we would have never had electricity by itself. Right? And there is a very, very high probability in case if this layers get diminished somewhere in middle, if the impact of the solar magnetic field has to be experienced, you would see the communication systems are affected. The GPS or the navigation systems are affected. The internet is affected. And more than anything, the electrical blackouts. You would have heard about blackouts. ब्लैकआउट क्या होता है? दैट पूरा ग्रिड कोलैप्स हो जाता है. इसका मतलब दैट ऑल ऑफ द वोल्टेज दैट इज एग्जिस्टिंग इन अ पर्टिकुलर ग्रिड collapses. And automatically what happens? It results in a dark region. Now I think in 2012, 2013, the northern power grid had collapsed. And that was the one of the worst blackouts that we have ever seen in the history of India. So in that context, what is happening? I see that the electrical lines also would have been affected if this is not there. Now, do you remember yesterday we had a question? Yeah, there. 2022 ka. I made you read the question before I started sunspots. Yes. Now, will you read that question again? Open that. You remember the question? 2022 solar storms. Just type, you will get. Yes. Easy. Now, in that, can tsunamis be generated because of solar storms? No. Because is tsunami an electromagnetic wave or water wave? Water wave. So, definitely, right? If tsunami was electromagnetic wave, can you swim? Impossible. Right? You would have been roasted. Right? वो अलग बात है, तो छोड़ो उसको. तो उसके बाद one more phenomena is there which will definitely not happen. Apart from tsunami, what else will not happen? Forest fire. Any reason? It can't happen. Why, my dear? That is a phenomena which is happening on the earth because of some friction activity, because of some wind system. No relation at all. UPSC tries to confuse you like this. But if you just understand the core concept, was that question easy or not? Right? Definitely that was a question of relief. At prelims mein kahi beach mein we will have those questions of relief. That you observe, go back and observe the question paper. Constantly you will keep having multiple statements. Suddenly UPSC will give you a single liner. And 90% of the aspirants mark those single liner as incorrect. Why? Excitement. Right? Till now you have been trained to read multiple statements, eliminate multiple statements. Suddenly you see a single liner. You're forced to answer that question even though you don't know. Why? Because most of the part of the paper you will anyway not know. Right? Isal, people were like in the exam hall when they came out, the first opinion, right? When I was taking the nation wants to know the public talk, people were like, very easy. Paper was very easy. Right? We marked 97, 99, 98, 102. I hope you know that in OMR we will also have till 150. Some people, when they don't know what is going on, they will mark all 150 and come. Right? हो सकता है, probable. There are some people. But what happens? On the face of it, it appeared easy because there were more single liners. But actually, that was very deceptive. Very deceptive. क्योंकि इस साल का कट ऑफ भी अराउंड 88 to 90. उससे ज्यादा नहीं. 88 to 90. Now, when it is 88 to 90, this was very similar to the cutoff of 2022, 2021. Only thing is that it was more understandable than 2023 paper. Understandable. Is it solvable? No. Easy? Definitely not. Because one thing we will have to keep one thing in head and go. UPSC prelims can never be easy. Please remember. UPSC prelims can never be easy, and if somebody is telling that UPSC prelims is easy, then that fellow either he didn't prepare or either he didn't attempt the paper inside the exam hall, he is attempting the paper outside the exam hall. Dekh lo, over and dekh lo. Right? If somebody would have skipped their attempt, they will definitely say, I should have attempted this. If I would have attempted this, I would have got 220 out of 200, definitely. बहुत चलता है एग्जाम आउटसाइड एग्जाम हॉल इट इज ब्यूटीफुल inside exam hall pathetic it is because more than anything, more than question paper, the examiner's face, the invigilator's face, right? He will be staring at you. And बीच में कभी यहाँ के अच्छा, I think this answer is this. Who asked you to tell? This goes on being there. Some aspirant would have been there who would not have cleared prelims once also. He got into teaching profession. Now he's one of the primary school teachers and he's invigilating you. What will happen? Excitement, right? So remember all of this. Remember all of this because prelims is a game of emotional management, balance, and it's a game of basics. Definitely a game of rock steady basics, and you will automatically clear. Okay. So now here, when we are talking about whole of this business here, now when I see this magnetosphere existing, what is categorically happening is this solar winds are seen to be constantly interacting. These solar winds are constantly seen to be interacting, and what is happening, my dear? These magnetosphere belts, these magnetic radiation belts are shielding the solar winds. They are shielding the solar winds. Now that means what is happening when they are shielding the solar winds? Don't you think there is a neutralization reaction which is going on? Now one simple analogy I will give you. You have seen this Kurukshetra serial Mahabharata, right? In that you see from one side they will fire one arrow, from one more side they will fire one more arrow, and the arrows will come. When they hit, what will happen? The neutralization bush like this, something comes there. Same thing happens. There is a sort of neutralization reaction which is fundamentally going on. Now here when I see this neutralization reaction which is going on, where I see that the magnetosphere of the earth is fundamentally shielding this solar winds which are existing, automatically what happens? I will definitely see some light energy being generated because I know that energy can never be created nor destroyed, it can only be transferred. That process goes. I see that there is some sort of light energy being released. Now, when these light energy is transferred to the poles, when these light energy is transferred to the poles, that becomes what? That is what is called as aurora. That is what is called as aurora. And I see that this aurora is called with different names in the northern hemisphere and the southern hemisphere. Aurora is nothing but these polar lights. Polar lights, and that is purely generated because of this neutralization reaction which is going on between the interaction of the magnetic field of earth and the sun. And when I see this in the northern hemisphere, this is what is called as aurora borealis, and in the context of southern hemisphere it is aurora australis. Australia is in southern hemisphere or northern hemisphere? Southern hemisphere. Australis. Aurora borealis. On later date you will study about boreal forests and all, right? So borealis is in northern hemisphere. So aurora borealis and aurora australis, southern hemisphere, northern hemisphere. Now here I was telling you that all of these magnetic winds or the magnetic field that has been ejected from the sun is being shielded. Now I see that these bells are fundamentally holding this energy for a while. These bells are fundamentally holding this energy for a while. And that region or those bells which are holding the energy of this magnetic field interaction which is going on between the magnetic field of the earth and the sun, this belt region is what is called as Van Allen belts. This region is what is called as Van Allen belts. What is this Van Allen belts? These are those belts or those radiation belts which are shielding and holding the solar magnetic field as well as the earth's magnetic field. Are you understanding? Right? That is what is called as Van Allen belts. Right? So what all did we discuss in this? Simple. One, we spoke about magnetosphere. We had seen the genesis of magnetosphere. We had seen that how it was shielding and how it has resulted in auroras. Then from there we talked about something called as Van Allen belts. We talked about something called as Van Allen belts. Now here we see one, I think last year we had one particular current affairs with respect to this particular dimension of the shielding, the magnetosphere, Van Allen belts. Now that was what was called as South Atlantic anomaly. Now this was fundamentally related to the magnetic sphere of the Earth, magnetosphere of the Earth, the radiation belts of the Earth. Now when I talk about the South Atlantic anomaly, before this, you'll have to understand that. Now first, suppose say if this was the Earth, I know that the axis of the Earth is tilted. Now when I look at the magnetic radiations, I know that this is how it is. Yes. Now one side constantly I see that there are solar radiations which are being shielded. One side. Now that means what is going to happen, don't you think? This is going to be more flat compared to this. Why? Because constantly I keep seeing this solar winds which are fundamentally interacting with this region. Right? That is what is called as dark side. I would call it as dark side or night side. Why would I call it as dark side or night side? Because that is not being exposed to sun. When I look at this particular region, I constantly see the solar winds being interacting, and slowly what happens? The belt region or the Van Allen belts or this magnetosphere slowly gets flattened. When it is getting flattened, don't you think it is getting closer to the Earth? When it is getting flattened, it is getting closer to the Earth. But whereas in this direction, what happens is you see that these magnetic fields are to be extended something like this. And this pure extension of these magnetic field lines is purely because of the impact of solar winds. Solar winds. And this extended version of this magnetosphere is what is called as a magnetotail. Is what is called as magnetotail. Magnetotail. Tail-like structure. Why the tail-like structure? Purely because of the impact of the solar winds, it is seen to be extending. It is seen to be extending. And whereas on this side, what is happening? Constant interaction I see on the side of the sun, on the side of the solar winds, I see that this particular region is becoming flat and flat and flat. And that means as it is getting flat, what is happening? It is getting closer to the Earth. The magnetosphere on one side is close, one side it is flowing. This is magnetotail, this is closer to the Earth. Are you understanding? Yeah. Because of the solar wind impact. Now here, what is happening when they were doing some necessary research on this particular dimension? They found that between the African and South American region, somewhere in that particular region, they found that these belts were becoming weak. These belts were becoming weak. And that weakening of this magnetosphere, that weakening of the radiation belts, that weakening of the Van Allen belts near the regions of Africa and America is what is called as South Atlantic anomaly. Is what is called as South Atlantic anomaly. Anomaly means what? Some sort of defect, some sort of variation, some sort of dynamism that is existing. Do you remember? We would have discussed about something called as gravitational anomaly. Do you remember gravitational anomaly? Yes, the gravity was varying with respect to equator on the poles. Yes, where was it more? The gravitation was more where? In which direction? It was near poles. Yes, why? Because I know that G is inversely proportional to R square. So when I find it inversely proportional to R square, automatically what is happening? I see that the gravity over the equator is less than the gravity over poles, because I see that the poles are flattened. When poles are flattened, I see that the radius with respect to the poles is less than the radius with respect to the equator. Are you getting this? Yes. So this is what is meant by South Atlantic anomaly, right? So with this, we finish the basic dimensions of planetary system.